Hello and welcome, guys. Welcome to my YouTube channel. So today, let's try to, I was thinking that we would be solving one of the contest from the lead code, which is 305. Let's quickly jump to this contest. So this contest is actually already over. So we are going to join the virtual contest and we'll try to, solve this problem. The reason I'm going to, solve this contest because yesterday I was participated into it and I was in a given time I was able to cover this. So I just wanted to discuss all the problems because every problems which is there in this contest is kind of a very good question has been selected into this, and this will help you to build your concept in data structure. Okay, so let me just open this question. Okay, yeah, let me start it. That doesn't matter. Okay. Okay, so let's quickly jump to the description of the problem is number of arithmetic triplets. You are given zero index, strictly increasing integer array nums and a positive integer diff. A triplet ijk is an arithmetic triplet and if the following conditions are met. Okay, so there is a nums array which is given and integer diff is given and there is a triplet ijk and it will be a arithmetic triplet if these following conditions are met. So what it is telling is I should be less than j and j should be less than k. And nums of j minus nums of I is equal to diff, nums of k minus nums of j is equal to diff. So let's see this example, it will be more clear to you. So here if you see, right, from this num and this is the diff which has been given, 1, 2 and 4 is the arithmetic triplet because these three are satisfying the condition. So what is the condition is that 1 is less than 2 and 2 is less than 4, right? And if you see the difference between these two, this is, I mean, these are the indexes, right? So basically at one index, what is the value is 1, and at two index, the value is 4, and the difference between these two number is equal to diff, right? And if you see the index 4, 0, 1, 2, 3, 4, right? 7. So 7 minus second index, if you do 4, the difference is 3. The same thing should be happening for the second, possible solution is you pick 4, 7, and 10. So 4, 7, 10 are also a triplet because the difference between these, any of the two number, I mean, in sequence, the difference is 3. Because 10 minus 7 is 3 and 7 minus 4 is 3. So I hope you would have got the idea what is this number of arithmetic triplet question it is asking about. So how should we do it? And one thing they have given is you are given a zero index is strictly increasing. So this number is kind of already sorted. The nums is already sorted. So we don't need to worry about the sorting. So one thing is for sure that if we iterate from the left and if we are somehow able to figure it out that the next number differences, then it would be, we don't need to check basically this condition because this is sorted, so this will be taken care in this. So, let's try to, solve this. So one thing we can do is, so for we can pick a number from this num and then we can try, we have to find another number, right? Whether the other number which is there in the nums, and it should be like plus 3 from that number, right? Because that's how it will be able to satisfy the second condition. So, and we have to only find the three number, right? That is also one thing. So let me quickly try to write the code. So what I'm thinking, right, to find a next number by plus 3, let's say that I'm starting from 1. So now I want to find whether 4 is existing into this array or not. So if 4 is existing, that will be my next, you know, that will be my next answer. I mean, I don't have to find the exactly all the numbers. I have to just find the counts, right? So I can keep counting, and once I will able to find the three numbers, I can say my answer is got increased by one, right? And that way I will be able to find all the answer. And I should try out I should start from every index and the same thing I should be doing, right? So what I'm saying is, let's say there is answer variable and I want to have a set, right? So let's push everything into nums, into set, right, from this nums. And let's try to iterate. Let me just get the length. So now I will iterate over this array. Um, I can have a temp variable called current count, which will keep a track from starting from every index, and it will keep a track whether we are able to find the triplets or not, right? Now, um, since I am starting from this, what I can do is let me, you know, get the current number. So let's say the current number is j. Now, while my j uh, is there in the set, right? It means what I'm saying is when I'm starting from 0, so if it is there in the set, obviously it would be there, the first number, right? So I can increase my count. I can say this value is 1. Um, right? I can just keep increasing that. And j should be changed to plus 3, right? Because now I have to find the next number, j plus 3. So if I'm starting from 0, the next number that I have to find is 3, right? If I'm starting from 4, I will find the next number 4, and if 4 I'm finding, I'll try to find the 7, right? So that's how I'm going to increase every time a 3 into it. Not 3 basically, right? It should be diff, because diff can be anything, right? So I will increment by diff, and once I will see if my current count, right, is greater, not greater actually. Um, okay, so every time I'm increasing, okay, it keep increase just 1 second. So let's say that from 1 I'm increasing 4 and 4 to 7, and then it will go for 10 as well, right? So here I have to find if my current count, right, is equal to, you know, length of 3. Then I can say my answer is I mean, it will increase by 1, and I can just break this loop, right? And then finally I can return my answer. Okay, so this answer is 2. What is the answer here? Answer is 2. Okay, let me try to submit it. Got submitted. So I hope this problem was easy and you would be able to, follow up whatever the approach I was talking about. Let's quickly jump to the another problem, because this video can be go for a this video will be very longer, right? Oh, no. So back to the contest. Let me choose another problem here. Okay, so reachable nodes with restrictions. So there is an undirected tree with n nodes labeled from 0 to n minus 1 and n minus 1 edges. You are given a 2D integer array edges of a length n minus 1. So where edges I is equal to flana, 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 right, indicates that there is an edge between the nodes A and B in the tree. Okay, so the edges, basically there is array has been given, which is denoting that there is a path between A to B, right? What we have to find, they have also given, like you're also given an integer array restricted, which represent the restricted nodes. Return the maximum number nodes you can reach from node 0 without visiting a restricted node. Note that node 0 will not be restricted. Okay, so this is the graph they have given, and this is an undirected graph. As you can see, what we have to find is, if you see the edges they have given, restricted is given, so 4 and 5 we cannot able to reach it, so we have to find how many nodes we will able to reach. So 1 2 3 4, right, this many nodes only we can visit. Okay, so basically in this problem, right, what we have to do is, this is a very simple problem, because if you know that how to traverse graph, right, then it is a very simple problem. Only what you have to do is, whenever you are visiting a node, anyway we can we keep a track of all the visited nodes, right? Just keep a track and push into one of the set or any places, and then just find the length of the set. That's what we have to do in this. So let's quickly, code it. So what I'm saying is, first let's create adjacency list, right? So for that I will create a default dictionary, which will be a type of a list. And what I will do is, let me, create one set. So there is a restricted nodes also given, right? So I just want to see, when I'm creating the agency list, I don't need to push those nodes into the agency list, because those are not reachable. So I want to, just filter it out, those nodes. So I will just say that restricted, this is my blog node, right? Okay. Now I have to create my agency list, right? So I will have a start and in ages. These are my ages. Um, in agency list from the start, I will just append the end. And agency list we have. I mean, since we have to, it is undirected graph, right? So we have to do, we have to add, we have to create a path from both end, right? So this what I'm going to do. I will create from start to end to start, both. Once my agency list is created, I will be having this. Okay, one thing I am missing is, if this is start or, right? Basically, if start is in, blocked node, or my end is in blocked node, right? If that is the case, just 1 second. Okay, if that is the case, right? Just continue. I don't need to do anything. Or then, I mean, we have to filter it out, right? All the block nodes. So our start and end, if it is there in the block node, we don't need to, create that, put inside the agency list, right? Then we'll have a visited dictionary, and simple DFS will work here. So let's say there is a node, how we traverse a graph. That's also very easy. You put a node, right? The starting node, which will be there, right, in the function. Then what we have to do, we have to say that this particular node, now it is visited, right? So make it true. And then what we have to do is just, find the next node, right, from the agency list, from this node. Okay. And then we have to see if nn is not in the widgeted, then only we have to call this DFS again. That's all. I mean, that's all the code we have to write for this, right? Um, this will be starting from zero because zero they are telling is note that node zero will not be restricted node. So it is safe to start from the zero, right? Once this is done, what we have to do is just return the length of the widgeted dictionary, right? Let me just see if this is correct or working. Okay, so there is some error, invalid syntax. Okay, oh, this shouldn't be there, right? 4, 3. So first answer is 4 and the second one is 3. I think it should work. Let me submit it. Oh, got submitted. So this is what the problem was. It's very simple, guys. Just a small DFS. I think the important logic was to use the block nodes properly so that you create a proper adjacency list. Okay, so let's jump to the next problem. Check if there is a valid partition for the array. Okay, so let's quickly jump to the description of the problem. You are given a zero indexed integer array nums. You have to partition the array into one or more contiguous subarray. We call a partition of the array valid if each of the opt-in subarray satisfies one of the following conditions. So the subarray consists of two equal elements. For example, the subarray 2, 2 is good. The subarray consists exactly three equal elements. For example, 4, 4, 4, right? Because all three are equal. Or the third one is consecutive increasing element like 3, 4, 5, right? So what they are telling is there is an array and we have to, find out whether we can divide this array into a valid partition, right? The valid partition can be of three types. One is either you have a subarray which of length 2 and they are equal. Either you have a subarray of length 3 where every elements are equal, or you have the length of 3 subarray where they are strictly consecutive increasing elements, so like they are in sequence. Return true if the array has at least one valid partition. So if any valid partition is possible, we have to return true. Okay, so I think the problem statement, it would have been clear to you. So how should we do it? So as you can see, right, these kind of problems, basically either you can go for the recursion techniques, because here you have to try out all the different places. Um, you have to partition many places and you have to try out all the solution, and then you have to find out whether any of the solution is returning a valid partition or not. So there is not one way which will we can I mean we can say, okay, this is the way it should be working. There is a multiple problems you have to think and you have to solve it. So that's why when there is a multiple problems, there would be multiple solution exist, right, at every stage. And for these kind of things, recursion is the best choice. So how do we do in the recursion? So if you follow the problem, right, one thing we have to notice is there is three different condition is given. So obviously, if these three conditions are true, then we can say that, okay, we are able to partition the given array, right? And that what we are going to use as our base case, right? Or in our recursion technique. So let me just code it so that it will be more clear, right? So let's say my function is def, and I'm just calling a dfs, right? So there is a index. Okay, so we have to iterate on this array, and we will try to partition from from first index. We'll try to partition from here, then we'll try to partition from here, we'll try to partition from here, and we'll see if any of this solution is holding true, right? And if that is the case, it means we are good, right? So that's what I'm going to do. So if my a is equal to, n, what is n? N is basically the length of nums, okay, the length of the array. Let's say we are able to reach to the end of this array, right? If that is the case, then we can say we are able to partition the array successfully, right? Isn't it? Because if we are not able to, partition the array in the initial way, we couldn't have, you know, we could not have, reached to the end of the array, isn't it? So that I mean that is one of the base case where we are saying is that we our index, I mean the index, we are able to reach it, and the previous values, I mean the previous partitions are holding true. So let's see, I mean how this will work. The other, the condition which is given is, the other condition which is given is, mm, yeah, this one, right? So the subarray consists of exactly two elements. So right, we have to first identify whether there are two elements or not. So let's say there is I, and I plus 1 is equal to n. If this is the case, right, so at the place where we are at the current position plus 1, I'm looking at from my current position whether there is a next element exist or not. If that is the case, right, if that is the case, it means, I mean, if that is true, so I can just go and try to find out if this condition, because if there are two elements and I'm able to see that these two elements are equal, then at least this condition are getting true, right? I mean, I'm able to divide my array into a sub array of two length, and which is going to be equal. I mean, that should be the condition. So I'm first checking whether I have two elements left in my current from the current position. If that is the case, I can say from this is my current position, and let's check the nums of I plus 1, right? And if this is correct, and the future, the future indexes which is there, like so what would, I mean, this is one partition I have done, right, from the given array of two length. Now I have to check all the other indexes after this two index, after my these two indexes, right? So that's what I'm going to do. So this is only checking the sub array of length 2, and this is checking. So first this has to be true, and then our, let's say there is an array of 5 lengths. So once I check like two indexes from 0 and 1, right? 0 and 1 is both are equal, and the rest three, of the length of that array from starting 2 and 3 and 4, right? If these are falling into either second or third, then I can say this is, I mean, there is a partition available, right? The valid partition can be done, right? So that's what I'm doing. First, I'm just thinking about if my this sub array of two length is holding true or not. If this is holding true, then I will check for my next remaining elements, right, from I plus 2. I hope this part you would have got it, right? And if this is the case, I can say that return true. Now I will just try for I plus 2, right? So if I have to see, I mean, if I have to put a validation or condition to check the second and third part, right? I need to have at least three elements. So how the three elements will come? From my current position. I is my current position plus two element, right? So I now there is a length of three subarray, right? And if it is there, it means if it is less than n, and nums of I is equal to nums of I plus 1, right? and which is equal to also nums of I plus 2. If this is the case, right? And again, this length of 3 subarray condition I am able to check, but what if there is more lengths? I mean, there are more elements exist in the nums, right? So I have to check all those future, I mean, extra remaining elements, right? So my DFS again should start from I plus 3, from the next three elements, right? And if this is returning true, I can return true. There is another condition is also given for the same length of 3, right? So what I will do is I will just explain this part. So what in the third condition they are telling is the subarray consists of exactly three consecutive elements. So length has to be 3, and now I have to check whether these are consecutive or not, right? So how can I check whether these are the consecutive or not? First I checked whether there are three elements. So to check whether these three are consecutive or not, what I can do is I can add 1 into a lower uh, index, right? Like I will add 1, so it will become 4, and I will subtract 1 from this last third one, right? So if all these three are equal, it means they are in a consecutive sequence, right? This is the middle one, and this is the last one, right? So nums of I plus 2, right? Minus 1, and DFS I plus 3, right? So once I checked these three, if this is the case, then I will check for the remaining elements. And if everything is hold true, then I can return true. If none of these things are, valid, then I can just say return false. This is all we have to do in this case. Let's quickly test it. Okay, I have to return this as well, right? So false, false. Actually, this is true and false. So somewhere we are doing a mistake. Hmm. So I plus 1 is less than n. No, if all the three are equal. Mm, 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 mm. So where the mistake is happening is, okay. Oh, yeah. This has to be nums I plus 1, right? This is I in which I added 1. This is middle one. This is, yeah, this should be the case. Yeah. So true, right? So true and false. So this is holding true. One more thing, guys. This case will also work. Let's say if you have the I, right, which is 3, right? And your n is equal to, the length is equal to 3, right? So this is basically a very base case. I mean, if you think like you have one element and your index is I, right? In that case, anyway, this will be valid partition, right? So either you able to reach to the last, or are able to, just I mean, the remaining elements are equal to the index, right? The current index. Okay. I mean, your current index is equal to the number of the lens. Like if you have one element and you are sit currently at that position, right? So I hope this part is clear to you. What uh, different condition I have just uh, coded here. Let's quickly submit it and see if this is working. Oh, okay. So it's taking a lot of time and it is going to be time limit exceeded. So I think I have to use LRU, cache here to make it working. Let me submit it again. Okay, got submitted. So now you can see this answer is got submitted. So let me quickly jump to another problem. Longest ideal subsequence. Okay, so let's quickly jump to the description of the problem. So if you see right, you are given a string s consists of a lower case letters and an integer k. We call a string t ideal if the following condition are satisfied. So t is a subsequence of the string s, and the absolute difference in the alphabet order of the every two adjacent letters in the t is less than or equal to k. Return the length of the longest ideal string. The subsequence is a string that can be derived from another string by deleting some or no characters without changing the order of the remaining character. Okay, so in this longest ideal sequence subsequence, what we have to find is we have to find the longest ideal string, right? And the longest ideal string is what we have to identify with this given k value, right? So let me just explain this example. So this is the string which is given, and there is a distance which is given, right? So the longest ideal string is ACBD. And why it is that? The length of this string is 4, so 4 is returned. The reason is because if you see the difference, right? A to C, what is the distance? So if you consider A index at 0, B index at 1, so what is the C index? C index is 2, right? So difference between these two, the length, the difference is 2, right? So if the distance of a character is less than or equal to 2 and they are in a sequential order, the way they have given into your original string, we can form the T, right? And we have to form a T of a longest one. Okay, the subsequence means you can pick this character in a given order only. You cannot change the order, only you can think of like some of the character you can remove it. That's all you can do, right? So if you see the A and C, the difference between AC is 2. And if you see the difference between C and B, the difference is 1. So this is also valid and B is coming in next order. And B, so we have to find the absolute difference. So it doesn't matter if your minus 1 is here is coming, right? Still the distance is 1 only, which is less than 2. And B to D, the distance is again 2, right? So that's why ACBD is your longest ideal string, and that's what we have to find. So how we are going to do it? So there are multiple, again, I mean, if you see the problem, this is also the multiple variation you have to try out, and then only you will able to find out, right, what is the correct answer. And if you see, this question is very much similar to the longest increasing subsequence. I recommend you guys to go and see what is the longest increasing subsequence, because this is one of the very important topic. If you want to learn data structure, don't skip the longest increasing subsequence, right? So first go and see what is the way of implementing the longest increasing subsequence, and then it will be very easy to follow this video. So I will show you the both the DP, the recursion, and then a greedy approach for this particular problem. Okay. So okay. So if I'm saying is that we have to try out all the possible, solution, then it means first somewhere the recursion has to be there, right? The recursion method has to be there, then only we can jump to the DP part. I mean, DP, obviously you will able to find out from the geeks for the longest increasing subsequence, and you can just, just ditto, you can copy and paste this code of LIS, longest increasing subsequence, with a given condition, a little bit modification, and this problem you will be able to solve. But in the Python, basically, I will show you this is not getting accepted because time complexity is used, and the reason is the length of the string what they've given is 10 to the power 5. So when the this constraint has been given in, then you can think is like n square solution is not going to work. So basically the DP problem of the LIS is in n square. Okay, I will explain the LIS in a very much detail in a different video, but let me just give you a hangs on, hang on, a little bit of, um, you know, idea about the how the LIS is going to work. Okay, so first let's try to solve this using the recursion. Okay, so I will just create a method called DFS, and if you see, what we need to do is we can choose any of the character from the given string, and then what we can do, we can try the next character, right? So if we are choosing any character, let's say I am starting from A, right? So now I have these many options to choose. So I have to start all the options. So again, I will choose this one, I now I have remaining these many options. So let's say this is not the valid one, this is not the valid one, so I will choose this one, right? And I can keep the the length of this chosen values, right? That's how I'm going to approach this problem. So the the template which I'm going to write it here, I will be using in most of the problems of the recursion. So you don't need to worry once, even if you're not able to follow up, there will be like 10 or 15 problems or 20 problems related to this template. I know recursion sometimes a little confusing, but don't worry about. Just stick to this particular implementation, and you will able to get it after a couple of videos once you will able to follow. So let's say I'm starting right from here, and if you see, I have to find you know so what I'm trying to do is I'm starting from here, right? But once I will reach here, I will see that what is the difference from the previous character. If my previous character difference is valid, right, which is equal or less than k, then I will add that particular, these string, substring into my or subsequence into my answer length. Okay. So for that reason, I want to, keep track of my previous character. So I will take another variable called previous. Now what I will do is if start, right, is equal to or greater than, again, I have to calculate the length of as. Okay. So now if my start is able to reach to the end of the, the string, it means there would not be any more, length to add or any character to add. So I can return safely 0. And then I can have a variable called maximum. Let me just call maximum length, right? Then I have, when I'm starting, so at every step I have, too many choices. I have, if I'm starting from here, I have this many choices, right? Correct? So from my start, I have this many choices, isn't it? So I will say I have, okay, I have these many choices here. So initially, right, initially the previous value would be 0, right? So what I can say is if my previous is equal to, let's say I'm just giving some, initially I will be initialize my previous value as a max size. So that's fine. I can say my previous is equal to max size, or if now I am trying to, find the difference, right? So if my previous value initially, I mean during the first character when I'm just starting, so that time my previous is max size, so I can ignore that case, right? I can just move on. Or if my previous is there, if that is the case, then what I can do is I can take an absolute difference between the current and the previous one, and I can say k. Okay. If it is less than k, then what I have to do is, um, then what I can do is I can add one into the answer, right? And DFS, I have to just start from next one. So let me just quickly explain this. I have to keep a variable also just to store it, right? So let's say include. Okay, include. So this is my temporary variable where I'm storing it, and then what I can do is max length is equal to max length equal to include, right? And that's what I'm going to return it. Okay, so let me explain this problem. So what I'm saying is, when I'm starting, wherever I'm standing, right, I have, from there I have too many choices. So I have too many choices till end, right? So this is my start index, and I can go from start to end, right? If my previous is max size, then what I can do, I can ignore and I can move on because that is one character, right? And I can say just add into one, just add one, and then explore the rest of the options. So rest of the option I'm saying is explore from I plus one. Okay. And the previous value will become the current value, right? This is what I'm doing. And from the next time, let's say that I was at 0 A, so I will ignore the previous condition and I will just move into my recursion call. And that time my character will be, I mean, the length would be 1. Then I will move to the B and I will see what is the difference between B and A. If it is less than or equal to 3, then I can add one more and I can say now from B I have C and D to check, right? So every time I'm increasing the starting index, and from the list of my choices I'm iterating and choosing one, right? Let's say that this value is not correct. I mean anyway we are starting from A, but let's say this is not correct, so I have this range, right? So if this is not correct, it will try for F, it will try for G, it will try for B. So at every step, when I'm saying a list of choices, it will try out all the characters. And every time I'm adding one, so during the backtrack, during the recursion call, once it will be able to reach to the best condition and when it will return, right, I will have my length. So I have to check what is, I'm just keeping a variable of to get the maximum length, right? Now, since this is a recursion, let me just put LRU cache here, right? And I have to also, call this TFS. So the start would be 0, and the previous initially I'm saying is that let's keep it max size. Um, I have to also return, right? Yeah. So let me just run it and see. Okay, X is not defined. Where is X? Okay, X is here. So, okay, one thing I'm missing is to find out the absolute difference, right? There are two options I can do here. Um, I can create one X and I can say that odd of the character minus odd of A for C in S. So this X I have created. So what this X is, I am taking all the I'm converting this string into a array of with their positions. Like A is going to be there at a 0 position, C positions will be like 3. So 1 to 25, sorry, 0 to 26, this is like A to Z, the indexes will be there, right? So I'm just converting into a proper index array. And this is what X is representing. So yeah, so this is one thing I'm going to do. Let me see, 4, 4. So you see the output is coming, right, correctly. Instead of this, I could have used, the direct, I mean, I could have convert here to find the position. So that should also have been work. But I just want to show you if I'll try to submit it, it will not be submitted because even though if I have put this LRU cache, there is a huge, time complexity. I mean, it is going to be in n square, which is not valid in this particular case. So the time limit is getting exceeded. So just let's skip this, solution, and let me, try to code the another solution. So now I'm going to code other solution which is LIS. So I will explain what is LIS problem in another separate video, but this is just a standard template of a DP which I'm going to use from the Geeks for Geeks, and this is very important if you want to know that how this DP and all is getting created. I will be covering that into a separate video. So in this case, what I will do is I will create a DP, how we create in the case of the LIS, and we will initialize with 1. The reason is, the one, at least one character would be there, right? The length of 1. So that's why we are initializing with 1. Again, there will be the length of S. So I will create this DP, right, of this length. And how we fill this DP is we start from, you know, range I, we start always from I to N because, um, right, you see the LIS, right? So basically you can start from the end of the array or you can start from the start of the array. Okay. Again, I have to fill the X, right, the same way, unless I'll miss it. So let me just create the X here. Okay. Now the J will be starting from 0 to I. And that's why we are starting from 1 because we want to see if the previous value, like J is representing the previous value and I is representing the the forwards values. So if you see, simply we have to check if you know um, X of I, right? If X of I minus X of J, right? And I have to do this absolute. And if this is the case, which is less than or equal to K, right? And one thing, one thing we do in the LIS, we also check that dp of I, if it is less than dp of j plus 1, right? If this is the case, so in the dp of I, what we do is we add dp j plus 1. You don't need to, you don't need to remember this code. Once you will understand what we are doing is basically, so just think like this is the array, right? So my index is starting from here, and I'm checking from this is representing j, right, which is starting from 0, and this is I. So I'm checking is if, sorry, yeah. So if my previous j is representing previous, right? So what I'm saying is if my previous in the dp value is there, and when I'm adding 1, if it is getting greater than 1, I, the current position, right? Uh, and only we will be checking if this condition is matching, right? In LIS, what we were doing is we were checking that, okay, Mike, this value is greater than this value or not. But in this case, we are not doing that. We are not checking whether this value is greater than this or not. We are just checking whether this value and this value absolute difference is less than or equal to k or not, right? This is only the difference from the LIS part. Rest of the thing is going to be the same, right? Once this is done, we have to just return the maximum value, right? What the maximum value we have found till now. Oh, sorry. From the complete DP, I have to, you know, do that. So that's all in this case. If you see, the answer is still 4, 4. And if I will try to submit, this will also not be submitted because here also the time complexity is in ON square. If you see, two loop we are running, this is not going to submit. Okay. So in this case also, it is not going to submit. So I cannot use this. So this is a very good problem actually, because in this, now we have to try something else, right? So one thing to notice, and just to let you know guys, this solution I did not come up with. I mean, this solution I was able to come up with, and even this solution I was able to come up with. But the greedy approach, I was not able to figure it out till the solution I saw it and able to, I mean somehow I got to understand, right? So basically in this case we are going to still use the same kind of the code, but instead of going from 0 to I, what we would be doing is, since we know that we have to see the absolute difference of a particular character, right, only to the k distance. And that k distance could be in plus, or that k distance could be in minus. What I'm saying is, if you are at B, right, and I'm saying one distance you can go. So how far you can go? From B, you can either reach to C plus 1, or you can reach to minus 1. So that is A. And if A is there and C is there, they will form this longest ideal string, right? And this is what the logic is. So in this case, we don't need to even create the DP for the complete n. We know that there would be always like 26 characters, right, from A to Z, and that is the maximum possibility. So we'll create the DP. Will That will be of length of 26, right? And what I will be doing is, let me just iterate over the string, right? So this is the string which is given. Okay, now for every character, right? I mean, here I am trying to, create the array in advance with their index position. But here, um, instead of that, I'm going to just use like, I can find for every character what is the index, right? The same thing I will be doing, like odd of, this character minus odd of, A. I could have used this array as well, right? That's not going to change the logic of this code. So once I'm able to find this particular, the index of a character, so I know that index would be there in this DP somewhere, right? So simply what I have to do is, for this particular index, right, what is the possible answer? I mean, what is the maximum length is possible? So I can say is 1 plus max of, right, from my DP, because 0 to 26 characters are there, right? I can say is max of 0 I minus k. I will explain what is this, so that it will be easy to understand. Then there will be min, um, this will be 25 and I plus k. Okay, so basically what I'm saying is, from this DP, right, which is having like 26 character of length, what is the minimum value is possible for a given I? So minimum value is possible is 0, or from my index, I can maximum go to minus k, right? This is my starting index. This could be my starting index. Even if it is going negative, I don't need to go, I mean, I cannot go in cycle, right? So that's where I'm saying is the minimum value which is possible is 0 or something else, right? Like if I am at C and I am saying that max k is equal to 1, right? So what is the minimum value? So C to B I can go, or if it is going negative, I will take the 0. That's why I'm using max. The same thing, how long I can go from C to one length. If k is equal to 1, how long I can go, right? So maximum I can go till 25, or I can go to I plus k, and that's why I'm taking the minimum of it, right? So I hope this would have got clear, right? And from this, new array. So so basically, just let me show you. So let's say currently I'm at C character, right? So C is nothing but A0, 1, 2, right? So this is 2. So I'm saying you can go k equal to 1, right? It means you can go to 1 to 3, right? This is your DP. So from this subarray, right, I'm going to find the maximum value. Okay, I hope you would be able to follow it. So I have to find the maximum value and then I will just say add one. Okay, and the reason to add one is because this current character is there, right? So whatever the length is there, if there is already some value stored, I will able to form a new length of plus one, correct? So that's what I'm doing here, and after that, from my DP, I can just return max. Okay, so I can just return max. So if you see, this is also giving the same answer, but this will be very fast, and this solution will be, you know, okay. So there is some mistake. Mm, 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 mm. Okay, I think, yeah, I have to consider this case plus one. I am thinking, let me just see if this is working properly. So 5, yeah, expected is 5. And the reason was, uh, this is my last index, right? So my array will be only iterating from here to, 1 minus of this. So I have to do a plus 1 in this case, right? Because I want to, um, you know, reach to till the last index, right? Let me submit it. Yeah. So this got submitted. So guys, let me know if you have any problem or any comments in the comment box. See you in the next video. Thank you.